Hello! In this video, I will provide an overview of our project on evaluating the Bloom's taxonomy-based modules for parallel coordinates literacy. With the ever-increasing use of charts in media to communicate and miscommunicate information, visualization literacy has become extremely important. Existing definitions of visualization literacy emphasize the need to read and interpret novel visualizations. But literacy also encompasses applying the learned skills in real-world settings and exhibiting mastery over the material. Bloom's taxonomy is a widely used framework by K-12 teachers as well as college instructors. It focuses on building recognition and understanding skills first, before providing learners with an opportunity to put those skills into practice through the Apply, Analyze, and Evaluate modules. The Create module provides learners with an opportunity to synthesize all that they have learned in a real-world setting. Here is an overview of the 6 modules that we developed and their corresponding learning goals. The first module teaches students to recognize and remember what a parallel coordinates chart looks like. In the second module, we introduce features of a parallel coordinates plot and how to read it correctly. In the third module, we ask students to apply their knowledge and construct a chart manually. The fourth module requires students to read parallel coordinates charts correctly and answer questions based on them. The fifth module asks students to critically evaluate charts. The sixth module requires students to create a chart using online tools given a real-world dataset. We now discuss the details of each module. The goal for this module is for students to be able to remember and recognize a parallel coordinates chart. We produced a training video to introduce students to the concept of parallel coordinates that included a variety of parallel coordinates plots. Students were then asked to identify the charts individually or in a lineup. Here are some sample questions from that module. The goal for this module is to help students understand how to interpret a parallel coordinates chart correctly. We developed training videos to explain how data is represented using a parallel coordinates chart. Our videos informed viewers how to follow a single polyline across the axes, how to identify correlation, observe axes labels, the minimum and maximum value for each axis, interaction techniques, and more. Here are some sample questions from that module. This module allows students to apply the skills gained so far to construct a parallel coordinates plot. Students constructed a parallel coordinates chart manually for a small dataset on books. When they were done, they were asked to upload a picture or screenshot of their chart. The goal of this module is to test the students' ability to derive observations from the presented data using parallel coordinates. Students were asked to trace multiple polylines, order charts in ascending or descending orders, and even compare the same data being shown as a scatter plot matrix and a parallel coordinates plot at the same time. Here are some sample questions from that module. The goal of this module is for students to evaluate charts based on the principles they have learned so far. Students were shown a wide range of parallel coordinate plots with defects that were intentionally introduced into the charts. Here are some sample questions from that module. The goal of this module is to provide students with an opportunity to synthesize all their knowledge and create a parallel coordinates chart. Students were given 2 datasets in CSV format and were asked to create a parallel coordinates chart using online tools. They also answered a few questions about the data based on the charts they produced. Students were asked to take a screenshot of their chart and submit it. To enable the comparison between the Corrective Immediate Feedback group and the No Feedback group, we showed both the groups of students the same questions, but for each module, the CIF group saw the first half of questions with immediate feedback and the second half without any feedback. Students in the CIF group were allowed to advance to the next question only if they answered the current question correctly. We then compared the accuracy of the questions for both the groups where they did not have any feedback. Let us now discuss the findings based on evaluating the students' performance. Based on the analysis of the student performance in the 6 modules, we found that students in the CIF group had higher accuracy in 5 out of the 6 modules. Students in both the groups performed well on the first 4 modules, but in the last 2 modules that required higher order thinking, students in the CIF group performed much better and had higher scores. We also found that students in the Corrective Immediate Feedback group were more confident in their ability to recognize, interpret, create, and use parallel coordinates plots in the future for data exploration. We present the results of an evaluation of Corrective Immediate Feedback on parallel coordinates literacy. We found that Corrective Immediate Feedback had a clear impact on the students' overall understanding of parallel coordinates plots. Students in both the groups learned about parallel coordinates through the modules and expressed high confidence in their ability to recognize the plots. The developed modules, training videos, CSV files used by students in various modules, study data, and scripts to generate the figures are all available in the GitHub repository linked here. Thank you for watching the video.